technical issues. In order to do the right thing, you have to have a lot of technical knowledge. You have to know a lot about it. So studying ecology can inform our environmentalism, so we more often than not do the right thing. But that's certainly true with the relationship between what goes on in the lake and what goes on in its watershed, or drainage basin. The more modification there is in the drainage basin, the more trouble there's likely to be for the lake. Natural terrestrial ecosystems tend to buffer, especially these chemical effects on lakes from the surrounding land. Vegetated landscapes tend to intercept these chemicals and tie them up in trees or plants of other kind. The surrounding wetlands of a typical lake, you know, that swampy area down at the southern end of Owasco Lake, is ecologically very important. I mean, not only does it filter things that are on their way into the lake, but it is also a breeding ground for various things that go out to the lake to live at some other time.
My name is Alan Kozlowski. I'm the current president of the Owasco Watershed Lake Association. We started this association back about 15 years ago in response to a water quality problem that precipitated from the state putting a new prison complex in the Moravia. And that system at that time couldn't handle the effluent from that system without being upgraded, and Owl was instrumental in trying to do some awareness raising with the state and the community to get that package put together, and it turned out to be a good place to draw a line in the sand in terms of water quality in Owasco Lake. And then the next issue came in was the Smith Corona, where they were going to put in a treatment facility to do, some of the groundwater had been contaminated by the cleaning chemicals from the machining process over a very long period of time in the village of Groton. And Owl again went to bat for the lake to try to do a better job of, in fact, this cleaning. They were basically going to clean the water and put it back into basically the inlet to Owasco Lake. And there were some assurances, or there couldn't be total assurance that in fact was going to be total effective without in fact leaching some of those elements back into our water system. And so Owl has been trying to do a more aggressive job of water testing. We have a volunteer group that goes around the lake and tests for coliforms all summer long. There's about 13 weeks of testing that goes on, and that program is gradually increased so that not only does it include the main body of water of Owasco Lake, but we've also now are testing all the way up into the watershed into Tompkins County. But that's coliforms. And the other element of any of the Finger Lakes or any body of water is basically the nutrient portion of the system. And that aging process that takes place in any body of water can be measured in terms of some basic elements, and one of those is phosphorus. And the testing that the Department of Environmental Conservation has done over the last 15 or 20 years, if you look at that data, it shows an increase in phosphorus in Owasco Lake as of the last number of years, versus in what it wouldn't be, or it isn't exactly a panic situation, but other Finger Lakes are going down in phosphorus. I'm sure most people remember that laundry detergents and stuff were heavily laced with phosphorus back in the 70s, and there was a lot of legislation to reduce that. That has happened. Particularly in Owasco Lake, though, our levels of phosphorus are starting to show some of the elements that were evident in that period of time in terms of levels. And we're very concerned about that. And a lot of that has to do with sedimentation. The phosphorus comes into the lake primarily through sediment. It attaches to soil particles, and we do have still some significant elements of erosion and so forth, runoff, that are taking place in our watershed that apparently are accelerating, or at least causing this process of phosphorus loading and aging of the lake to be an area of significant concern for all of us. The Buoy project that we have in conjunction with the Institute for Applied Geospatial Technology is a significant step forward in terms of our measurement of some of those elements. It doesn't do anything with E. coli or coliform counts. Those are pretty much still based on our dip tests at the end of people's docks. But the buoy itself doesn't measure phosphorus, but it measures elements like chlorophyll that would be a relationally element to phosphorus, so that we could get a better handle on some of those types of accelerated things that we're concerned about. So that in that connection between our lake and the other lakes is important, so that we can measure not only are we in jeopardy in some area versus other lakes, are they accelerating faster than we are we taking care of it as good as we could. And I think therein lies really Owl's future endeavors, is that we feel strongly that the current state of the lake is certainly not bad, but it is not getting better. It is in fact slowly increasing in some of these levels of phosphorus and so forth that would lead us to the conclusion, and some of the data that we're getting back would suggest that this loading of elements, nutrients, is in fact resulting in algae growth, weed growth. We've had some changes in invasive species in the lake. We have some weeds now that we never had before. We certainly have zebra mussels now that we never had before. Consequently, the zebra mussels have filtered a lot of the sediment or the floating in suspension type materials in the Owasco Lake, or in really all the Finger Lakes and in the Great Lakes. That has resulted in clearer water. So the perception, I think, in terms of people's minds, that the lake is cleaner, when in fact it's just clearer. And that clearer element basically lets a lot more sunlight through. Sunlight then produces, with this extra phosphorus that we have, then produces algae. And algae is blooms. I mean, it's basically a plant that floats in the water. And that blooming, that life cycle of algae, that bloom or that accelerated growth, and then as the weather cools down, it dies back off again. That process does, in fact, impart, in some cases, some taste elements to the water. So not only does it affect the oxygen levels and so forth, but it also affects some of the basic aesthetics of the lake in terms of what the water looks like or smells like, or when you get a drink out of your tap, what it tastes like. And so all those things are types of concerns that we really are not sure of what the bottom line is, but none of them, in terms of history of lakes or in terms of the history of our lake, are positive things. Those are all things that are question marks at best and probably problems at worst. And so Owl is really working hard to increase our watchfulness of these things, to try to measure more accurately and more scientifically what changes are in fact happening, and then also to start to do physical changes with the watershed to reduce this sedimentation issue and stuff that we know exists today. If we could reduce the sedimentation in the lake, it would reduce the phosphorus, it would reduce the aging of the water body, that would reduce the algae blooms and the bounces of the lake in terms of those elements, and should result in the long run in long-term water quality. The fix, though, isn't easy, and it isn't splashy. It isn't like building a new seawall that now you can walk on and it's beautiful and there's nice bricks and stuff. Basically going back up into these streams and fixing every one of those cuts and providing better growth of different types of filter strips. This is all hard work. It's all pounding away at elements that are difficult to get people excited about. And so Owl is committed to trying to increase awareness of how important those things are. They're small steps, but if you take a whole bunch of those little steps over a period of the next 50 years, then that water quality for our children will be enhanced significantly.
Profiling buoy. Basically, this is the floating platform, okay, on which we are going to put our other platform, which is going to hold our electronics. It's going to hold our data logger and communication elements, and it's going to hold up there our meteorological sensor tie-ins, okay? All of this electronics will be enclosed in these hoods and those will snap on over, one on this side, one on that side. Those will snap over everything, keeping it weather tight, weather resistant. And here are going to be the solar panels that will keep this driving, okay? The purpose of this system is to give real-time water quality monitoring 24/7, so you can have the data transmitted back to your desk. And the second real purpose of this is you really want a profiler. And when I say profiler, I mean your water column is here, your body of water is here, and a lot of systems or a lot of people can only get single point things that relatively close to the surface. This system will enable you to get to the bottom of your lake with this winch type system over here. The reason you want to go with something like this is because this is going to give you the whole water column. So you'll get here, then you'll get here, then you'll get there, and you'll get 24/7, and now you have the capabilities of sending this data right back to your desk. So you don't have to go out there and monitor, you don't have to go out there and grab samples. Basically, this whole thing is called the sonde, and these are called the sensors. And these sensors are actually are going to be doing the work of the actual monitoring. This is your chlorophyll sensor. This is your dissolved oxygen sensor. This is your conductivity and temperature sensor. And this is your turbidity sensor. And this is your pH sensor. The other way that people were getting data beforehand was to go out and do what is called grab sampling, which is to go out, grab a sample, and send it to the lab. Obviously, you're very limited by manpower, you're very limited by time, and it's very costly. To go out and get that sample, the physical process of going out, collecting the sample, sending it in, waiting for it to come back is a time-consuming, laborious process, and you're very often left with very limited, small amounts of information.
The 6 parameters that are being measured here are temperature, specific conductivity, dissolved oxygen, pH, turbidity, and chlorophyll. Chlorophyll is a measure of the amount of phytoplankton biomass present. Turbidity is like they measure at a water treatment plant, the cloudiness of water. pH, temperature, specific conductivity, dissolved oxygen, those are traditional water quality parameters widely used to characterize bodies of water like this. Lakes like this thermally stratify during summer, and we can track that through temperature measurements. pH is an interesting parameter for a lake like this. It tends to go up during algae blooms, and this lake undergoes the phenomenon known as whiting, and the precipitation of calcium carbonate. It makes the water look cloudy. It's really not a water quality problem as such, but all that can be tracked indirectly through pH measurements. Oxygen is, of course, an important water quality parameter, and out here in particular we'll use that to track the rate at which oxygen is lost from the lower layers. That's a widely used indicator of the productivity or water quality of lakes. Additionally, this unit has a meteorological monitoring station on it. So folks can access the local prevailing weather conditions, at least out on the lake, wind direction and speed, incident solar radiation, air temperature, that kind of thing. There's always a concern as to how eutrophic various bodies of water are, so the levels of chlorophyll are concerned, certainly turbidity is a concern. And with regards to a cold water fishery like this lake has, obviously we are concerned that enough oxygen remains in the lower waters year-round. But we think it's a darn good idea that they want to be vigilant and have a monitoring unit out here, and it is certainly a way to learn more about the lake, understand how it works, and get the community involved in those processes.
Critical, I guess, place to start is this issue of temperature in the lake. And it's an interesting issue because water, pretty much uniquely among liquids, substances in general, is most dense at a middling temperature, and especially at around 4 degrees centigrade, which is about 39 degrees Fahrenheit. And since in a climate like this, it gets much warmer than that in the summer and much colder than that in the winter, and since the lake is heated by the environment, and especially by sunlight coming into it, it goes through that magic 4 degrees C every year. So if we start and imagine it in the summer, the sun's baking down on the lake, and it's accumulating heat. And because of wind currents blowing over the lake and so forth, what happens is that heat gets mixed down into the lake, and the water warms up until, September or sometime, late in the summer. Temperature of Owasco or Cayuga Lake is, say, somewhere in the 20 degrees, 25 degrees centigrade range. And if you start measuring the temperature going down in the lake, it stays pretty much the same for, let's say somewhere up to 10 meters, 12 meters, maybe 20 meters. But the first few tens of meters into the lake differ for different lakes. And then, all of a sudden, the temperature starts to decline as you go deeper and deeper in the lake. And it declines fairly suddenly, fairly steeply. So that by the time you've gone through another 5 meters or so for a lake like Cayuga or Owasco, you're back down to water that's pretty much in that 4 degree centigrade temperature range, because that's where it's the most dense. And because that heat has been mixed down only to this area where the temperature changes rather quickly with depth, that's called the thermocline. It's very hard to get that bottom water at 4 degrees C, that most dense water, to mix with the upper water. And so the thermocline therefore divides the lake into two sections, a top section and a bottom section, by temperature and therefore by density. Now if you imagine what happens in the fall, it starts to cool off. And the air temperature around here on the average gets a lot colder than that 39 degrees centigrade. The top water starts to cool off. As it gets cooler and cooler from 20 degrees centigrade down to 4 degrees centigrade, it gets heavier and heavier. And as that water gets heavier and heavier, it makes it easier for the whole thing to mix up. And at some point, the whole lake is at 4 degrees centigrade as the top water cools down and the bottom water stays at 4 degrees centigrade. And when it's all the same it's all the same temperature, it's all the same density. And once it's all the same density, there's no resistance whatsoever to turning it all around. One of the measurements I imagine your buoy makes is a measurement of turbidity in the water, of ability of the light to penetrate the water. We like nice, clear, clean water, right? Well, the turbidity in the water may be caused by the sediments washing in from the streams. The principal issue, especially out in the middle of the lake, is how much phytoplankton is growing. And if there's a lot of phytoplankton growing and the lake tends towards being eutrophic, and what limits the amount of phytoplankton growing is not how much sunlight you have typically, it's what kind of fertilizer you have, what kind of nutrients you have. And so when this eutrophication starts to happen, one of the first places you'll see it is in the ability of light to penetrate into the lake, the measurement of turbidity of the water.
It'll be a very interesting test, and I think we can break some new ground in this whole area of research by using this buoy. So it's a great asset to our area, I think, for the research community. Well, what we use is, unlike a normal camera, the satellite has what we call bands, and it's got 16 of them. So whereas a normal, color camera might have 3 bands, the red, green, and blue, the satellite actually has 16 or more, and they range from anywhere in the visible, which is what our eyes can see, up and through the thermal infrared. So these discrete channels are measuring the light levels, electromagnetic radiation in very discrete bandwidths. So what we like to use are anywhere from the visible to the near-infrared bands, and we're using them to look at the lake water clarity, but we need the Secchi disk measurements, and hopefully the buoy will be able to supply these measurements for us, so we won't have to go out on the lake every time, and use a regression model to interpolate the known areas with the unknown areas. So say we know that at this point where the buoy is, it's the water clarity is 5 meters or something, and there's a certain color around that buoy that we can see in the image, and certain values in those 16 or however many bands. And so what we do then is use a regression to match that color up with the rest of the other colors that we see in the lake. So what we're doing is saying to the regression model is, here is my pixel A, and the Secchi disk measurement here was 3 meters. And the spectral value for this pixel, was this for all of these bands. And so we then perform a regression that looks at all the other pixels in the lake and assigns a estimated lake water clarity depth to each one of those pixels. And our end result will be a map that shows what the estimated lake water clarity depth was. And then what we would like to do is use the buoy to substitute for those field measurements so that we can have a more automated process.
So there's a whole toolkit now that just has become available in the last few months that is going to be critical over the next, again, decades to, in fact, ensuring that we're not doing development around the lake that is going to be harmful, directly harmful to the watershed. And we can do both. There's no reason that development around the lake can't happen but be scientifically done so that, in fact, that the aftermath of subdivisions isn't a polluted or a very dirty lake, that in fact we can do that to help clean the lake or keep the lake really clean at a high level, which is really what I think Owl's after too. Is it we're not talking about leaving the lake in the natural state with no development, no people living on it or around it or nobody using it. It's just the opposite, really. We're trying to say, look, we're a community that the lake is an integral part of all our lives. We drink the water, we swim in the water, we fish, we water ski, we do ski jets, we do all the things that we do to lead full and happy lives and recreation packages. And there isn't any reason with today's science that we can't really encompass an awful lot of that. I mean, there's obviously some limitations to everything, but basically we should be able to live and benefit from this water body without degrading our life or taxing us to death or any of the above. We should be able to do both things because we have some of these new science things available now that are able to tell us how to do things in a way that would be incrementally positive rather than incrementally negative to, like, this phosphorus loading issue. Some of those things boil down to, what can I do? What can I as an individual do to help my watershed? What is Owl suggesting here? How do we go from just living in the watershed to, in fact, helping be part of the solution rather than the problem? And it boils down to just becoming educated about the watershed. A lot of this material is on the web. We have a website, owla.org, and we talk about different ways to fix streams. These are also linked to extension service, educational packages that would talk about fertilization of your lawn, lawn clipping, waste, and then again, like I talked about, that we were working with towns so that people that live in your town should go to a town board planning meeting once in a while and ask the question is, what are we doing in our town to help our watershed? You don't have to go to every single planning board meeting. You just drop in once in a while and raise your hand and ask more about that. What is the town of Fleming or Owasco or Niles or Moravia, Scipio, Venice? What is my town doing to make sure that the watershed is in fact being monitored and looked at from my town level? So there's really, in the city of Auburn, the same way. What does my water taste like? If your water tastes funny, you should call the water department. Talk about with them what elements are, what's the city of Auburn doing to monitor our watershed and make it better.